Okay, boys. Today we're going to be talking about 4-1, but not really 4-1. I'm going to call it 4-1 because some of the elements of 4-1 are there, but it's really not 4-1. It's a little mix of 4-1 and 4-2, but it's all under the same blanket of quadratic equations. Basically today and this week we're going to learn how to graph quadratic equations in both what's called standard form and vertex form. I'm going to show you also how to convert between standard form and vertex form, what the use of vertex form is, and then after that we're going to move on to the family of functions. It's going to be a very graphing intensive section because I'm going to show you how to shift and translate, compress, and stretch just about any type of function. So it's all going to start with the quadratics, okay? So you have part 1 here. Part 2 will be done tomorrow. It's a lot of stuff that we're going to have to absorb, but it's very simple, and I think that you'll be able to enjoy this video very much so. Okay, first of all, graphing quadratics, okay? When we're talking about a quadratic function, by now you should all know that we're talking about y equals ax squared plus bx plus c, or in other words, f of x equals ax squared plus bx plus c. You hopefully know by now, and you remember that y and f of x are the same exact thing, where a cannot equal 0. If a equals 0, think about this, y'all. If a equals 0, 0 times x squared, it's gone. So what am I left with? What kind of a function? What kind of a function is that? No, that's a kind of polynomial. It's a binomial. But when x is raised to the first power, it's a linear function. You guys forgot that already? Y equals mx plus b, same thing? Okay. So if a is 0, guys, what happens is the x squared goes bye-bye, and you're left with a linear function. So a cannot be 0 here. Now, the quadratic function produces U-shaped graphs. And these U-shaped graphs are called parabolas. Okay? Now, the a and the b are called coefficients because they are being multiplied to a variable. The c is the y-intercept. Okay? And this y-intercept is a constant. Now, this a, the little a, is going to do a lot for you. I mean, a lot for you. The a is going to determine if it goes up or down, and if it's a stretch or if it's a compression. So let me explain what all of this means. If a is greater than 0, in other words, if it is positive, then the graph opens upwards. Period. So if I have, for example, f of x equals 2x squared plus 5. You know right off the bat, immediately, one thing you know is that at least it's going to point upwards. Okay? Because a is greater than 0. If a is, and look what I did here, if a is less than 0, please change that, guys. Please change that. Please change that on your PDFs, please. And thank you, I apologize about that. If a is less than 0, in other words, it's a negative, then the graph opens downwards, literally. So if I have y equals negative 3x squared plus 5x minus 2, you know for sure that that graph is going to be pointing downwards. If that graph does not point downwards, you messed up. Yes, sir. Well, we had said that if a equals 0, it's not a quadratic function anymore. Thank you. Thank you, sir. It wouldn't look like anything because it wouldn't be a quadratic equation, son. Like we had stated already, if a is 0, you're going to be left with this, which is a linear equation, which is a straight line. So if a is 0, you don't have to worry about it opening upwards or downwards because it won't open upwards or downwards because it will not be a parabola. If a is 0, you have what's called a linear function. So, if a is positive again, if it's greater than 0, notice that's why it's not greater than or equal to 0. If it's just greater than 0, opens upwards. And if it is less than 0, then the graph opens downwards. The C. The C is the y-intercept, my friends. Okay? And the y-intercept is the y value when x equals 0. So if you plug in 0 for x, you will be left with your C value, which is the y-intercept. Now, parabolas are symmetrical, all right? If you remember back when you guys were kids, and it was Valentine's Day, and you guys were small, or Mother's Day, you would fold a paper in half, right? And then you draw one half of a heart, or a letter, or a star, or whatever, and then you cut it, right? You guys remember that? That's the perfect example of symmetry. Symmetry is when you cut something in exact, perfect halves. So when you did that little experiment or that little project for your parents or your mom or whatever back when you were kids, you were, believe it or not, working with symmetry already. So, for example, you put your hands together, okay, thumbs away from each other, you fold them in together, your thumbs will touch pretty much the exact same points. Remember, our hands aren't exactly equal, but roughly that's symmetry right there. You put a straight ruler right in between your eyes and it goes down and it cuts your nose in half as well. It's cutting your face in equal halves. If you were to flatten out your face and go around that axis, it would be symmetrical as well. So the line that cuts a parabola into these perfect symmetrical halves is called the axis of symmetry, okay, which is an invisible vertical line. And it is found by using the formula x equals negative b over 2a. And since it's an x equals equation, gentlemen, as you can see, okay, this dashed line here, it's invisible, but it is an x equals equation, so it is a vertical line. Okay? It's a vertical line. That's my line of symmetry. Yes, sir. Okay? Come again? Yes, I want you to actually write x equals negative b over 2a. I am sorry that I've made you write one thing today. I'm sorry. Yes, sir. It's never going to be a solid line because the axis of symmetry is an imaginary line. But it is only going to be used to help you graph the equations, sir. Vertical line is solid when it's just when they say something like x equals 5. That's a vertical line going through the x equals 5. But as far as a parabola goes, the axis of symmetry cuts it in half. Now, if you focus over here on the graph on the right, you're going to notice a couple things I labeled for you. First of all, you have a vertex. A vertex, I like to call, that's the swivel point of the parabola. That's the point through which the axis of symmetry goes through, and it's either going to be a maximum or a minimum value. And we're going to talk about that in a second. But as you can tell, if the graph is opening upwards like this, that's going to be a minimum. Because isn't that the lowest point of all the points on this graph? And if it's pointing down, if a is negative, then I'm going to have a maximum because that will be my highest value in that graph. Also, I want you to pay attention to these right here, the intercepts. What did we talk about those? What are those? Those are the intercepts, but those are also known as the solutions. Thank you. That's what we've been working for. We learn how to find these solutions by factoring, square root method, completing the square, or quadratic formula. You have all of those skills in your pocket now. That's why I wanted to wait to do this until you had all of those skills really locked up, gentlemen. Okay? So your x-intercepts, those are the actual solutions. That's the x value when y equals 0. That's the whole point of this graph, to find those solutions. Does that make sense so far? All right, let us continue then. Now, I talked about this vertex thing, okay? I talked about this vertex thing. The vertex of a parabola determines the maximum and or the minimum of the function and is found by using the formula negative b over 2a. That's my axis of symmetry that we just talked about. Remember that that's an x equals equation, right? So that's the x value. Once I plug in that x value into the function, I plug it in, then I find my y value. So simply plug in the value of the axis of symmetry, comma, into the quadratic formula, and then solve for y, also known as f of x. So for example, if I find that the axis of symmetry is 2, I'm going to plug that 2 into all of the x's of my quadratic formula. The y value that I get, well, okay, that's going to be my vertex then. That x and that y. Now, let's talk a little bit about the max and min again. If a is greater than 0, if a is positive, remember that the graph will open upwards and there will be a minimum. Please look at the blue graph here. This is my vertex and that's my minimum. If I wanted to, I would have an axis of symmetry going down the middle. You're going to see why I love the axis of symmetry in a little bit. Please notice also, my friends, that if a is less than 0, okay, it's a negative value, then the graph opens downwards, and there will be a maximum. Check out the red graph. That's a maximum. And again, there is an axis of symmetry going down there. So far all we know is that when you're looking at a function ax squared plus bx plus c, you're looking at a parabola. It's a U-shaped graph. If a is positive, it's going to be pointing upwards, and the vertex will be a minimum value. If it is negative, it's going to be pointing downwards, and the vertex will be a maximum value. Does that make sense so far with everybody? And also, we learned that the axis of symmetry cuts the graph symmetrically in perfect halves. Does that make sense so far? And we know how to find the axis of symmetry. This axis of symmetry is found by x equals negative b over 2a. They're with me so far? Yes? Okay, great. Thank you, gentlemen. Now, what does the graph of a quadratic function y equals ax squared plus bx plus c, aka parabola, look like? What are the significant parts of the parabola? I've given this to you already, but now here I'm going to solidify it. Because after this, now we're going to look at the actual procedures. So I need you to really focus, gentlemen, and really remember these. This is the key to this section. If you remember this, you'll be able to graph infinitely forever. First thing I have here, I have a parabola, and it is pointing upwards, okay? So we know that my vertex is going to be a minimum in this case. Now, the axis of symmetry, it's in green, x equals negative b over 2a. My y-intercept, that's the y value when x equals 0. And of course, it's going through the y value, right? The y-axis. And my vertex is my axis of symmetry, which is negative b over 2a, comma.
Take 4 yards into the attendant's office at this time. Take 4 yards into the attendant's office.
Sorry about that. And once you plug in the negative b over 2a into your function, then you get your y value. That's why I have f of negative b over 2a. Think about it like this. It's f of x, right? But isn't this x? So I'm plugging that x into the function. I think that made sense for some of you guys. Does that make sense? Okay. Thank you, gentlemen. Okay. Now, let me just show you real quick what happens to parabolas as the a changes. Remember how I told you the a is huge? Okay? We're going to be talking about the a in huge detail tomorrow. But for right now, look at what happens as I change my A value. What's happening? Now, I know this says B, but what's changing here, guys? The A. If I increase this A originally, it goes to the cube root. See what I'm saying? So trust me, guys. I know what I'm doing. What's happening to this graph as my A is getting bigger and bigger? It's getting thinner. What happens as it gets smaller and smaller? It widens. Okay. Try to remember that, guys. Okay? Now look. Oh, why did it go downwards when the A? Because it's negative. Very good. Okay? See what I'm saying, guys? So A is very, 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 very important. It's a straight line when A is 0, sir. Now, how to graph a quadratic function. Mickey Mouse time, guys. Ready? Here we go. Let's graph f of x equals 2x squared minus 8x plus 9. Please, 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 please follow these steps. These steps have never failed me. They are super easy. Looks complicated, but I promise you it's not. Let's check it out. Find the axis of symmetry. It's negative b over 2a. Okay, so in this case it's going to be 2 over 2 times 2, which is 2. So x equals 2. So you know what I'm going to do with that information? I'm going to go down here and draw an x equals 2 axis of symmetry. Thank you, son. Good job. Does that make sense, boys? Yes, sir. No, remember? What was the b value? Negative 8, right? So what's a negative times a negative? It's a positive. Thank you for asking and caring. Thank you, brother. Everyone with me so far? Yeah. Vertex. Remember how I said the negative b over 2a? You already calculated, didn't you? So now let's plug that in, guys. So this is going to be 2 times 4, because 2 squared, minus 16 plus 9. 8 plus 9 is 17 minus 16. Boom, 2, 1. That's my vertex. What do you think I'm going to do with that information? What do you think I'm going to do with that information? I'm going to plug it in. There's nothing to plug it into. I'm going to graph it. So 2, 1 is my vertex. Already, is this going to point up or down? Up. So is this going to be a maximum or a minimum, my vertex? Very good. This is a minimum. Right off the bat, you see how much information you have? Step 3. Find the y-intercept. In this particular case, it's Mickey Mouse. When x is 0, what's the y? Guys, when x is 0, what's the y? Guys, when x is 0, 2 times 0 squared minus 8 times 0 plus 9 is 9. 0, 9. What do you think I do with that information? Now here's the magic. All of this is worth it right now. My friends, if this is truly an axis of symmetry, and it cut things into perfect half, isn't this y-intercept literally 2 places to the left of the axis of symmetry? Yes. So with my logic, shouldn't there be a point 2 places to the right of it? Yes, sure. And guess what? Oh, that was horrible. Oh, that was horrible. That was pathetic. Here we go. And guess what? You just graphed your equation. Now, sometimes your vertex and your y-intercept are the same. If that is the case, you gotta go to number 4. If needed, choose 1 or 2 x values, plug them into the equation, and solve for y. Plot the new points along with their mirror image. That's if the y-intercept and the vertex are the same. You had a question, sir?
Yeah, how did you get the point on the bottom?
You mean my vertex? I already went over that. I plugged 2 into the equation. Come again? This is the vertex, 2, 1. This is the y-intercept, which is 0, 9. If you guys forgot about how to graph points, you're in big trouble. Sir.
Since it never crosses the x-axis, does that mean there's no solution?
I'm very proud of you. The question here was, Mr. Morrow, since it never crosses the x-axis, there's no solution? Yes, there's no solution. This is where I was going to clean all of this up now. You can tell immediately, because of what my boy said, that there is no solution. However, didn't we learn something called the discriminant?
Yeah.
If I go b squared minus 4 times a times c, wait a second, that's 64 minus 72. That's a negative 8. So is that gonna have any solution?
No.
So you can test and check your graph with this knowledge. Does that make sense? If it did go through, are you really going to be able to tell exactly what x's it went through on a graph? So how would you find the solutions to this? I know that this has no solution, but what methods can you use to solve? Quadratic formula, completing the square, you can factor it, or you can use the square root method. Okay? Does that make sense so far? Okay. Let's wrap it up then. Okay, let's graph x squared plus 9 plus 8x. First of all, I did this on purpose. What's the first thing you should do here? Very good. Rearrange it so it's in the proper format. ax squared plus bx plus c. I'm going to kind of go through this relatively quickly. Please try to stay with me, gentlemen, please. Axis of symmetry. That's an x equals negative b over 2a, which in this case is going to equal negative 8 over 2, which in this case is negative 4. So x equals negative 4 is my axis. 1, 2, 3, negative 4. I'm going to graph my axis of symmetry. Step 2, vertex. Plug in that axis of symmetry into the equation and find your y. Negative 4 squared is 16. Minus 32 plus 9. So that's going to be negative 16 plus 9. We're looking at negative 7, right? So I'm going to go negative 4, negative 7. It's right there. That's my vertex. Is that going to be a maximum or a minimum, just out of curiosity? Which is going to be, guys? I hear both. Okay. Which way is this graph going to point? Up. Why would you say down when the A is positive? This is pointing up, so this is going to be a minimum, guys. My y-intercept, when x is 0, y is 9. Okay, and let's just do a test point just for giggles. Just for giggles. Let's go ahead and choose when x is 1. When x is 1, we're going to get 1 plus 8. Oh, no, that's way too much. Let's do negative 1 to make our lives a little bit easier. So you're going to have 1 minus 8. That's negative 7 plus 9 is 2. Okay. So now, my y-intercept is 0, 9. So 0, 9. My mirror image, that's 1, 2, 3, 4 to the right. So go 1, 2, 3, 4 to the left. And then my extra point, just for giggles. Did I need it for this parabola? No, I did not need it. I only need it when the y-intercept and the vertex are equal. But let's just go ahead and do it anyways. Negative 1, 2. So I got negative 1, 2. So that's 1, 2, 3 to the right of the axis. So go 1, 2, 3 to the left of the axis. Connect the dots. And you have a perfect graph. Now, this is what I was talking about. Are my solutions here perfect? Guys, are those solutions perfect?
No.
How would I find my solutions to this? Would you really complete the square, guys? Guys, I would use my brain a little bit more. X plus 1 and x, no. Wrong. You cannot graph. You cannot factor this. Because it's 1 and 8, and that's not 1 and 9. You're never going to get a positive. So this, you're going to have to either complete the square or use the quadratic formula. So real quick, This would be negative b plus or minus square root of b squared minus 4 times a times c over 2a. So this is negative 8 plus or minus 64 minus 36, 28. 28 over 2. So this is negative 8 plus or minus 2 square root of 7 over 2. So guys, believe it or not, these solutions here that you can't really tell, they're right here. You could have simplified it to and just gone negative 4 plus or minus square root of 7. Absolutely. Give me one pause minute. Okay, so questions? Yes, sir. You don't understand how I did number 4? I plugged in x as negative 1. So I plug into this equation, son, negative 1 where all the x's are. Negative 1 squared plus 8 times a negative 1 plus 9. 1 minus 8 plus 9. God, that's 2. Okay? Yes, you can plug in any number. Thank you. Except, why would you not plug in negative 4? Because that's already the vertex. Okay, now, let's see if this makes sense. Consider the following, x squared minus 4x plus 9. Is this going to be a maximum or a minimum? It's going to be a minimum for sure. Why? How do you know that? Because x squared is positive. Very good. Now, what would the maximum or the minimum be in this situation? Ooh. Well, we're making numbers up here. Remember that the maximum or the minimum, remember that when you're talking about a max or min, aren't you talking about the vertex? And didn't we already talk about the vertex? It's the negative b over 2a value for the x, and then the y value once you plug that x in. So for this particular case, whenever you have to find the vertex, you're going to have to find the axis of symmetry first. So the axis of symmetry is going to be negative b over 2a, so that's x equals 2. Now plug that sucker in and find the y. 2 squared is 4, minus 8, that's negative 4, plus 9, 2, 5 is my minimum. Does that make sense? Does that make sense, boys? Alright, so now, this is very, very important for you to be able to do. What if I just give you, I have a few seconds left, a few minutes. What if I say graph, whatever, I'm going to make one up. F of x equals, I don't know, x squared plus 6x plus 8. Okay? This is what I'm going to expect. That's why it's every other odd. There's a lot of work here. This is what I'm going to expect for every single question, and I have it on video to prove it. Every single time you graph me an equation in this section, I want to find the axis, and I want you to label axis. So it's going to be negative b over 2a, so x equals negative 3. You got to do that, period. 2, you got to show me your vertex. Your vertex is going to be negative 3, comma, that's 9 minus 18 plus 8, so that's negative 1. That's my vertex. And next to the vertex, tell me if it's a max or a min. In this case, it'd be a minimum. 3, the y-intercept. The y-intercept in this case is 0, 8. Is the y-intercept and the axis of symmetry, are they the same? No. So do I have to use an extra test point? No. I only use an extra test point when the vertex and the y-intercept are equal, my friends. Go ahead and graph it now. Okay? Now, to graph it, like I said, as I'm calculating, I always graph. X equals negative 3, that's my axis of symmetry. My vertex is negative 3, negative 1. My y-intercept is 0, 8. That's 1, 2, 3 to the right, 1, 2, 3 to the left. Bada bing, bada boom. Now, what if I said to you, I want the solutions? In this case, we got lucky and they look pretty awesome. Sometimes you don't get lucky. How would you find the solutions to that? Okay, everyone's always going to the quadratic formula. Are you forgetting the basics? Try to factor it first. This is x plus 4 and x plus 6, plus 2. So doesn't x equal negative 4 and negative 2? Check, check. Does that make sense, guys? You do not need to find this last part on the homework. I will ask you, though, maybe, what are the exact solutions? You're not going to get them from the graph really ever. You're going to either get them from square root method, factoring, completing the square, or quadratic formula. Thank you very much. May God bless you. Have a great day.